Okay, in this video we're going to go over the 5.1, 5.2 worksheet. First problem is simplifying the trigonometric expressions. So all I'm doing here is I'm breaking everything up into parts. Sine squared, I just left it straight out. I did cotangent as cosine over sine. X goes to both of them. And then cosine, and then this is times sine. So here you can see these two sines cancel out, and I'm left with sine squared plus 2 cosines is cosine squared. Using the Pythagorean's identity, sine squared plus cosine squared is just equal to 1. Remember, these are the identities that you need to have memorized. You will not be given these on your reference sheet. Okay, this is the identity that I was talking about. Sine squared plus cosine squared is equal to 1. All right, part B. Okay, secant times cosine divided by tangent. All I did here was convert each one. Secant is the same thing as 1 over cosine. Cosine is just cosine. And then tangent I left in the denominator. These two cancel out, leaving it 1 over tangent, and I just simplified it to cotangent. Now, there are other ways you can do these problems. Just do the one that, as long as you get the right answer at the end, it will be correct. Okay? Number 2, okay, verifying the trig identity. Remember, when you're verifying, you're wanting to make sure that this side of the equation is equal to this. Always work on this side of the equation. So 1 minus cosine squared, sine squared. Remember, you need to know these identities. Okay, 1 minus sine squared is cosine squared. Then I'm going to do secant is the same thing as 1 over cosine. Okay, I can break them up, sine times sine over cosine, and sine over cosine is the same thing as tangent, and I just brought that sign here. When you're doing these types of problems, it's always best to look at what you're trying to get. That's kind of always going to be a hint of what you need to do. Part B, we're using Pythagorean's identities again. This time we're doing secant minus 1 is equal to tangent squared. That's where I get the tangent squared here. Cosine squared, just write it down again, and then I break it up into sine squared over cosine squared. Times cosine squared, these two are eliminated, just leaving your sine squared, which matches on the other side. Okay? Number 3, part A. Proving the identity, we're just going to make sure this equals this. 1 plus tangent, using the identities again, remember you have to have these memorized, is equal to secant squared. Secant squared, cosine and cosine, and then I can break this up, is 1 over cosine, and a cosine over here. These two eliminate, leaving me a 1 over cosine, which is the same thing as secant. Okay. Part B, I'm using now the sum and difference identities. Sum and difference identities are from this worksheet. You do get these formulas, so you don't have to memorize this. Sine with a plus, sine with the plus, I'm using this formula. My x is the u, my v is the y. So all I did here was expand it. Sine x cosine y plus cosine x sine y. Notice that the sine x is on the outside, so I kept outside of the parentheses. Plus, plus, and then I expanded the cosine plus. Cosine plus, I use this formula, again, putting it in parentheses. Okay, so all I'm going to do is expand that. Here I have cosine x, cosine y, minus sine x, sine y. Notice that the cosine out here is a cosine x. I left that outside of the parentheses as well. Okay. Now what I'm going to do is I'm going to go ahead and distribute the sine x into the parentheses. So now that I have a sine x times sine x, I can say sine x squared times cosine y plus cosine x sine y sine x. Don't try and combine these tricks to be the same. They need to be individual functions. Plus, cosine is now going to be distributed into the parentheses. So cosine times cosine is cosine squared x times cosine y minus minus, because this is a plus, this doesn't change, sine x, sine y times cosine x. Okay. Now I'm going to combine like terms. Notice that this term right here is the same as this term. It's rewritten differently, but they're exactly the same. Cosine x, sine x, sine y, sine x, sine y. This is a negative, this is a positive, so these cancel each other out. What I'm left with is just your sine squared x cosine y plus your cosine squared x cosine y. What's in common with these two? Hopefully you said cosine y. So in the next step, I just factor that out. I said cosine y is on the outside. Inside my parentheses would be my sine squared x plus my cosine squared x. What is sine squared plus cosine squared equal to? Using the Pythagorean identities, it's equal to 1. So all of this is equal to 1 times your cosine y. So your answer on this side is just cosine y, and it matches what we have over there. So this, we just proved this identity. All right, number 4. Again, proving the identity. Okay, all I did here was convert. Secant is the same thing as 1 over cosine. Sine over 1. Tangent is sine over cosine. Okay. Now that I have a common denominator, all I did was combine the numerators. 1 minus sine times sine is sine squared over cosine. What is 1 minus sine squared? Again, using Pythagorean's identities, it's going to be equal to cosine squared. Okay. Now that I have cosine squared divided by cosine, I can eliminate the denominator with one of the cosines in the numerator, leaving me with just the cosine x. That matches what we have on the right hand side. For part B, this is not the same thing as Pythagorean's identity. I need you to make sure that you don't get those two confused. Notice here it says cosecant squared, and if I subtract 1, that would be equal to cotangent squared. But this says cosecant not squared. It's to the first power, minus 1. This square is on the outside. You're taking this entire part and you're multiplying it by itself. Okay, it's not the same thing as Pythagorean's identity. And I'm just going to go ahead and break it up twice. It's cosecant x minus 1 times cosecant x minus 1. Cotangent squared x, that is Pythagorean's identity. I got that from here. Cotangent squared x is equal to cosecant squared x minus 1 if I subtract 1 from both sides. So in the denominator, I went ahead and converted this using Pythagorean's identity. Why did I choose to convert the denominator? Because if you notice on this side, you want everything in terms of cosecant. You do not want in terms of cotangent. Okay? If you remember, this is the same thing as the difference of perfect squares. So I can actually rewrite this as cosecant x plus 1 times cosecant x minus 1. This cancels with one of the ones in the numerator, and I'm left with just cosecant x minus 1 divided by cosecant x plus 1. Matches what we have on the right hand side, so we just prove this identity. Alright, next one. For number 5, all I did was rewrite the original term, which is here, cosine x, 1 plus sine, and then I found the conjugate. Remember, the conjugate is the same thing except the opposite sign in the middle. So 1 minus sine x. And I multiplied it in the numerator and the denominator because this is a term of 1. Okay? Now you can do first times first, last times last. So 1 times 1 is 1. Negative times positive is negative. Sine times sine is sine squared. In the numerator, I just rewrote the terms. I put cosine first and then 1 minus sine x second. Okay? From the denominator, I went ahead and used Pythagorean's identity and said that this entire thing is the same thing as cosine squared. Notice I have 1 cosine at the top and 2 at the bottom, so I'm able to eliminate the 1 in the numerator with one of them in the denominator. Now what I did was I broke up the denominator into 2 parts. I put it with the 1, so it's 1 over cosine, minus, and then I did sine over cosine. Okay? Then I went ahead and converted. 1 over cosine is the same thing as secant, minus sine over cosine, same thing as tangent, and it matches what the other side of the equation equals. Okay. There are other ways to do these types of problems, so please keep that in mind. It doesn't have to be exactly my way. Okay. Part B, notice we have 2, so the first thing I need to do is find a common denominator. Since I can use Pythagoras' identity to get this one, I'm going to change everything over to sine squared. Okay, let's go ahead and do that. First thing I need to do is use the conjugate of 1 plus cosine, which is 1 minus cosine. I'm going to leave the other term exactly the way it is because nothing needs to be changed. First times first, 1. Negative times positive, negative. Cosine times cosine, cosine squared. The numerator is just 1 minus cosine. This one stays exactly the same. Now, when I convert this using Pythagoras' identity, I get the common denominator of sine squared. So notice that the numerator does not change. I just rewrite it, and I changed everything over sine squared. Negative cosine and positive cosine cancel out, leaving me with just a 1 plus 1, which is 2, over sine squared. 1 over sine squared is the same thing as cosecant. So our answer is going to be 2 cosecant squared x, and as you can see, it matches the other side. Okay, number 6, cosine of 75 is the same thing as saying cosine of 30 degrees plus 45 degrees. Okay, use the identities provided on the reference sheet, and we're going to use cosine with the positive, this top. So cosine of 30, cosine of 45, minus sine of 30, sine of 45. Use your unit circle to evaluate. All right, let's evaluate. Cosine of 30 is going to be square root of 3 over 2. Cosine of 45 is going to be square root of 2 over 2, minus sine of 30, which is 1/2, times sine of 45, which is square root of 2 over 2. Multiply the interiors when you have radicals. So 3 times 2 is 6, minus square root of 2. All of that over 4. Don't forget to multiply the denominators together. Okay, so you have 4. You can check this on the calculator fairly easily by just plugging in the numbers that you're given. But for this particular test, you're going to have to show your work. Okay, I'm going to go ahead and I put my calculator in degree, and I'm going to go ahead and do cosine of 75. Okay, that gives me that answer. And then I'm going to go ahead and check my work by doing the square root of 6 minus the square root of 2. And I'm going to divide all of that by 4. As you can see, it's the exact same answer. Okay, right? Number 7 is going to be going in the opposite direction. Okay, here you're given the actual equation and you're trying to match up which one it looks like. We're given sine cosine with the minus, sine cosine with the minus. So we're going to be using this side. Identify your angle, that's your u, and the one that's your v. So here I'm going backwards. Sine of u minus v. So sine of u, 11 pi over 30, minus v, which is pi over 5. Use the calculator in this case to find what the answer is. All I'm going to do is use the fractions. So 11 over 30 minus 1 over 5. Okay. Second PRB, that gets me pi over 6. Use that unit circle, pi over 6, sine, that's going to be 1/2, and here's my answer. Okay. All right, number 8. All right, so number 8 is a type 3 problem. What you're doing here is you're going to be given 2 pieces of information. You want to make sure to draw your triangles in the correct quadrant. Make sure to stay organized on these problems because it's really easy for students to get mixed up. I'm going to start with alpha here. Here's my alpha. Quadrant 3, quadrant 1, 2, and 3. And I'm going to say cosine is equal to negative 3 over 5. Remember, cosine is adjacent over hypotenuse. So your negative is going to be negative 3 over 5. Use Pythagorean's identity to solve for your y value. In this case, it's a 3, 4, 5 triangle, and you have to remember that your y in quadrant 3 is going to be negative, okay? So what I did here was say cosine of alpha is equal to negative 3 over 5. That was given. And then I found sine of alpha is equal to negative 4 over 5, okay? Next one is in quadrant 1, so I drew my picture. And I said sine is 4 over 5. That means opposite over hypotenuse, so it's 4 over 5. That leaves x to be 3. It will be positive because x is positive in quadrant 1. And then I wrote down my cosine of beta and my sine of beta. Okay? It's asking us to find cosine alpha plus beta. So I put that formula here. And then I'm using the reference sheet equations, cosine with the positive, to match. So cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. Since I did my work and I kept it organized, I use alpha in the first one and beta in the second one. It's easy for me to match up. Cosine alpha, negative 3/5. Cosine beta is positive 3/5. Minus sine of alpha, negative 4/5. Sine of beta, 4/5. Okay? Now I can multiply. Negative times positive is negative. 3 times 3 is 9. 5 times 5 is 25. Negative times negative is positive. 4 times 4 is 16. So now I can simplify. Negative 9 plus 16 is equal to 7 over 25. These are a lot harder to check. It's not impossible, but it is a lot harder to check using the calculator. So make sure to write all your steps down and you can get at least some partial credit. Alright, number 9, we're going back to proofs. Remember here now we have negatives inside the parentheses, which means we have to determine if these functions are odd or even. Okay? Secant is going to be the reciprocal of cosine, and cosine is an even function. So secant is also even. So sine is an odd function, so that means this negative has to come out in front of sine. Well, when I do that, I have a negative times a negative, leaving me with a positive. So there's my sine x. Tangent is also an odd function, so the negative is going to come out, and it's going to be negative tangent x. Now I can simplify. Here I'm going to go ahead and say this is the same thing as 1 over cosine. Positive times negative is negative, and then I simplify the tangent. Sine over 1 and sine over cosine. Notice now I have the same common denominator, so I can just write everything over cosine. The numerator is going to be 1 minus 2 sine x is sine squared x. 1 minus sine squared is going to be the same thing as cosine squared divided by cosine, leaving me with just your cosine. So now I can see that these two match, and I've just proven this identity. Okay, number 10. Okay, we're going to be using the sum and difference identities to help us with this. So I'm going to bring out my formulas, and I'm going to start with cosine that has a negative, cosine negative. This is going to be my u, this will be my v. So cosine x, cosine y, plus sine x, sine y. There's a sign on the outside, so I'm going to put that on the outside here. Minus, minus. Now I'm going to use the sign with the negative, which is the second one under sine here. This is my u, this is my v. Sine x, cosine y, minus cosine x, sine y. Notice that this cosine is on the outside of the parentheses, and I have it on the outside of parentheses here. Now I'm going to simplify by distributing the sign into the parentheses. So notice that there's no other sine x on your first term, so I'm just going to rewrite all terms. Cosine x, cosine y, sine x, right here. I rearranged them, but it's the same thing. Plus and plus. Sine x times sine x is the same thing as sine squared x times sine y. Okay. Over here, I distributed the negative and the cosine simultaneously. So negative times positive is negative. Sine x, cosine y. Negative times negative, positive, and then distribute the cosine here simultaneously. Cosine times cosine is cosine squared times sine y. Okay. Now I'm looking for common terms. Here, even though it's written differently, you can see that each one has the same term. There's a sine x here and a sine x here. There's a cosine x and a cosine x, and there's also a cosine y. This is a positive number, this is a negative number, so positive 1 minus 1, these two will cancel out. That leaves me with each of these. So then I just rewrote the terms that I had left. I have sine squared x times sine y plus cosine squared x sine y. Noticing that I have a sign in common with both of these terms, I go ahead and factor that out, leaving me with just a sine squared x plus a cosine squared x. And what is sine squared x plus cosine squared x? Hopefully you said 1, so that leaves me with just sine y, which is what is equal to the other side of the equation. So let's do the last problem, part B. Okay. Here we're using the identities again. You have a sign and it's a negative, so I'm going to be using this one here. This is my x, this is my y, this is my u, this is my v. So sine of x, cosine of y, minus cosine of x, sine of y. All divided by cosine of x, cosine of y. I took this denominator and I broke it up into two parts, one to each of the numerators. As you can see here, I have sine of x, cosine y, sine of x, cosine y, divided by the denominator, minus cosine of x, sine of y, cosine of x, sine of y, divided by the same denominator. Okay? I do this because then I can see that these two can cancel out, and these two can cancel out, which leaves sine over cosine, which is tangent, the minus sine over cosine, that's tangent, and they're both the variable of y, so I have y here, which matches what I have on the other side. Okay, so we just proved this identity as well. All right, that's the conclusion of 5.2 worksheets. You need to practice these as much as possible. They will be on your test. Let me know if you have any questions. Thanks.